Hey kiddos, here's the spiral review for spiral 12. We're going to start off with some systems of equations. And first off, we've got a system that's written what we call standard form, where the x's line up with the y's line up and the numbers line up. This is a really good case for an elimination problem. And I think it's really good for that because no variable is really easy to get by itself. But it's not too bad if I want to try to make coefficients the same. Because I've got a positive and a negative, I'm going to try to get rid of the y's for this problem, although it doesn't matter which way you decide to do this. I'm going to multiply by the opposite coefficient. So for the top, I'm going to multiply by 5, and the bottom, I'm going to multiply by 2. The goal is to get the y's to have the same coefficients but opposite, and hopefully when we do that, we can eliminate this thing pretty quickly. So we've got 5 times 3x, 5 times 2y, 5 times 21, which gives us 15x plus 10y is equal to 105. On the bottom side, we've got 2 times 2x, 2 times negative 5, and 2 times negative 5. So that'll be 4x minus 10y is equal to negative 10. Since I've got opposite signs here, now I can add those together. And we get 19x, 0, and 95. When I divide by 19, we get x is equal to 5. I'm going to plug that into my equations. So I might say 3 times 5 plus 2 times y is equal to 21. 15 plus 2y is equal to 21. And that gives y is equal to 3. To make 2y equal to 6 is our answer. For the next one, I decided to give you a nice substitution problem. I see a y by itself, and that makes a really good substitution problem for us. That means that we're going to substitute 3x minus 7 in for y in the second equation. So 5 times y is going to become 5 times 3x minus 7, then plus another 11x, and that's equal to negative 139. That's going to be 15x minus 35 plus 11x is equal to negative 139. Combining those, I get 26x. I'm going to add 35 to both sides, and that's equal to negative 104. When I divide both sides by 26, I get x is equal to negative 4. And then I've got to plug it back in. So y is equal to 3 times negative 4 minus 7, which is negative 19. For number 5, I noticed two things. The first is that we've got a squared thing. I'm going to have to do some factoring. And the second is that both of these are equal to y. So that means I can set them equal to each other. 2x minus 13 is equal to x squared plus 2. I know I've got to make it equal to 0. And I like keeping my x squared positive. So I'm going to minus 2x from both sides. There's nowhere to minus that, so I'm going to put it at the end. And I'm going to add 13 to both sides. That gives me 0 is equal to x squared. I'm going to write my minus 2x next. And then we've got plus 15. This is not going to work out for us because I messed up when I made the problem. So I'm going to rewrite this very quickly and make this a minus 2 and a plus 13. So that should be a minus 2 and a plus 13, which means we're going to minus 13 from both sides, giving us a negative 15. And by golly, now this is going to be factorable. I've got an a times c that's equal to negative 15. With b of negative 2, that's going to be negative 5 and positive 3. So we get 0 is equal to x minus 5 and x plus 3, which means that x is equal to 5 and x is equal to negative 3. We can plug these into either equation. I'm going to use the top one because it's a little bit easier to work with. And we get y. So we got y is equal to 2 times 5. I gotta remember that's plus 13, and that's going to be 23. For the other one, we got y is equal to 2 times negative 3 plus 13, and that's going to be positive 7. Alright, I think that's it for this page. Next up, we've got a system equation word problem. And what we don't know in this situation is going to be how much a glass of milk and how much 2 tacos cost. So I'm going to call this T for taco and M for milk. And that's going to be how much each one costs. So a breakfast taco, T, plus a glass of milk, M, is equal to $2.10. For 2 tacos, 2T plus 3M is going to be $5.15. In order to do these, I'm going to multiply the top one by 2. And that's going to give me 2T. Let's make this negative 2. So negative 2T minus 2M is equal to negative 420. And that way I can just add these two together. And I get 0. I get 1M. And I get $1.05. And by that, I mean 95 cents. So that means that 1 glass of milk is 95 cents. And if we've got taco plus milk is $2.10, that means that taco is going to be $1.15. I guess on this page I'll also talk very briefly about the second equation for number 9. So we've sold 8 more sundaes than banana splits. So that means I might say something like sundaes is equal to 8 plus banana splits. For the other part, we've got 2 times sundaes plus 3 times banana splits, and that's equal to 156. Next up, we've got properties of exponents and polynomial basics. For the first one, I've got this mess of a thing going on here. I'm going to do kind of a cheating thing to deal with this exponent, and that is I'm going to do 2 parts at once. The first, the negative, means I'm going to flip this first piece. So this will become 4x squared y over 3x y to the 4th. And that's to the 3rd power. We got 12x to the 4, 5y squared. Okay. Each of these is going to end up getting a 3rd power. So 4 to the 3rd is 64. So that's 4 to the 1, 3 to the 1. X to the 6th, y to the 3, over 3 to the 3rd is 27. X to the 3, y to the 12. That's going to be times 12x to the 4 over 5y squared. Okay, multiply across. 64 times 12. Ugh, that's really gross. I might reduce those by 3 apiece and get 9 and 4. 64 times 4 is going to be 256. And on the bottom, we got 9 times 5 is 45. That's my number part. X's. X to the 6 times x to the 4 is going to be x to the 10. And y to the 3rd on top. On the bottom, we're going to have x to the 3 and y to the 14. That's going to finish up as 256 over 45. x to the 10 over x to the 3 is x to the 7. Y to the 3 over y to the 14 is y to the negative 11. Or you could rewrite this as 256 x to the 7 over 45 y to the 11. Kind of a gross problem. That's at the hard end of anything you might see for this. Number 11 is going to be pretty similar. I'm going to deal with this 3 first. That's going to be 2 to the 1 to the 3, so 2 to the 3 is 8. X to the 9, y to the negative 18, times 2x to the 3, y to the 12. 8 times 2 is going to be 16. Those numbers stay separate. X and x is going to be x to the 12. Then we get y to the negative 6. That leaves us with 16x squared and x to the 12, sorry. And to get rid of the negative 6x point, we're going to move it to the bottom and make it y to the 6. For number 14, we're doing some combining like terms. We get 3x to the 5, and there's no other one, so that's just going to be on its own.
Sorry.
We're going to have minus 5x to the 3rd, minus 2x to the 3rd. It's minus 7x to the 3rd. Plus 3 minus 6 is going to be minus 3. And then I still have minus 2x squared, which is plus 2x squared. I can leave it like that, or I can rearrange from highest to lowest power.
No, with the family. We didn't go away or anything.
For number 16, we can do 3x squared times 4x to the 3rd. It's going to be 12x to the 5th. 3x squared times minus 3x squared is minus 9x to the 4th. 3x squared times 5x is plus 15x to the 3rd. Minus 2x times 4x to the 3rd is going to be minus 8x to the 4th. Minus 2x times minus 3x squared is going to be plus 6x to the 3rd. Minus 2x times 5x is minus 10x squared. And we get plus 1 times 4x squared is going to be 4x to the 3rd. Then we get minus 3x squared and plus 5x. Going down is going to be 12x to the 5th. Minus 9 minus 8 is minus 17x to the 4. 15, 21, 25x to the 3rd. Minus 13x squared and plus 5x. A lot of steps in this one. Next up, we got polynomial factoring and graphing. For the first one, I notice that these two things have 4 pieces, and I don't know why I said these two. And what might be happening here is this might be one that's already set to factor by grouping. So I'm going to try to do that. For the first two, I can just take an x squared out. That's the biggest x I can pull out. And I'm left with 3x and a plus 5. The second two I can take out a 4. I'm going to take out a minus 4 to make everything positive. And I'm left with 3x and a plus 5. Hey, that worked out really well. That gives us x squared minus 4 and 3x plus 5. From here we got a couple options. The easiest is recognizing that this is a difference of 2 squares. That would be x plus 2, x minus 2, and then 3x plus 5. The other way is instead, starting from here, going x squared minus 4 is equal to 0, which means that x squared is equal to 4. When we take the square root of both sides, we get x is equal to 2 and x is equal to negative 2. Those are the same 2 zeros I would have gotten from that. Then we got 3x plus 5 is equal to 0, which means that 3x is equal to negative 5, and x equals negative 5 over 3. I'm going to sketch the graph of this before I answer the questions, because I think that's a little bit easier. I also might get from this the y-intercept, which is going to be that last number. And here we've got, so negative 20. And our points are going to be at 2, at negative 2, and negative 5 over 3 is less than, or greater than negative 2, rather. I also notice this is a positive out front, so we're going to go up and to the right at the end. Okay, nice smooth graph going through all my points, no bounces, because nothing is squared, and we have a shape that looks like this. Now we'll look at end behavior. Going to the left, we're going down and to the left, so I'm going to say this is down, and that means that we're going to negative infinity for the y. As x approaches infinity, that's going to the right, and we're going up as we go to the right, so that means that we're going to positive infinity. For the next part of this, we've got a graph, and we're supposed to write something in factored form. I'm going to start by writing the factors, and I'm also going to write that we've got a couple bounces here. One is at negative 4, and one is at positive 1. That means that whatever's going on for those is going to be squared. So we've got, for x equals negative 4, that's going to be x plus 4. We do the opposite. And that's a bounce, so we're going to make it squared. At x equals negative 1, that's going to be the opposite, so x plus 1. And at x equals 1, it's going to be x minus 1, and that's a bounce also. So that's squared. The last thing we need to do is figure out what number is out front. And to do that, we're going to use the y-intercept. So I'm going to plug in 16 for y and 0 for x. 0 plus 4 is going to be 4 squared. 0 plus 1 is going to be 1. And 0 minus 1 is going to be minus 1 squared. So that would be 16 times 1 times negative 1 squared is positive 1 is equal to 16, which means that a is equal to 1. Which again, you might have gotten if you didn't bother to do that step. You got to be a little bit careful, but often you'll find that those come up pretty nicely. For the next one, I set it up so you would have to do that. So have fun. Okay, then we got the new stuff. We got some polynomial division, and we're going to start by dividing this by long division, then check it with synthetic and decide if we have some factors or zeros going on here. I guess I'm doing the second one on video. I think I just did that because I don't know. And I know I have to figure out what multiplies by x to get to x cubed, and that's going to be x squared. I'm going to distribute that down. That gives me x cubed plus 7x squared. I'm going to subtract, and when I do that I get 0 and 5x squared. Bring down the next piece, so plus 29x. I then repeat the process. X to get to 5x squared is going to be plus 5x. When I distribute that down, I get 5x squared plus 35x. And when I subtract, I get 0 and minus 6x. Bring down the next piece, minus 33. And I repeat the process. To get from x to minus 6x, it's going to be minus 6. I'm going to distribute to give me minus 6x and minus 42. Whew. I can multiply good. And then I'm going to subtract. This is why I always use parentheses, because I need to remember that minus, 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 oof, that's a lot of minuses, might end up being a little bit funky. So minus 6 minus negative 6 is going to be 0. Negative 33 minus, well, I'm going to just call that plus. Excuse me. Negative 33 plus 42 is going to be plus 9. Since I can't divide anymore, this is my remainder. So I'd write that as plus 9 over x plus 7. Okay, using synthetic division, the first thing I need to know is that whatever would make this 0 goes out front, so that would be negative 7. My coefficients go on the inside, 3, 2, 1 number. I'm not skipping any, so I don't need placeholders. So we get 1, 12, 29, and negative 33. All right, bring the 1 down. I know I always multiply, put the answer up above, so negative 7 times 1 is going to be negative 7. I'm going to always add going down. 12 plus negative 7 is going to be 5. I multiply again. Negative 7 times 5 is negative 35. And I add going down. 29 minus 35 is going to be minus 6. And then I multiply again. Negative 7 times negative 6 is positive 42. And that gives me 9 as a remainder. The next piece, I have to rewrite this as a polynomial. The remainder goes over the divisor, x plus 7. Then we have the number, so that's going to be plus the remainder. The next piece is going to have an x, 5x. The next piece is going to have an x squared, 1x squared. You're always going to increase the powers by 1 as you go to the left. The other hint is that the power here, squared, is 1 less than the original power, which was cubed. Okay, down to the questions that I told you I will always ask. Is x plus 7 a factor? No. We had a remainder of 9. And then the second part is x equals negative 7 is 0. That's the same thing. We had a remainder of 9. And because of that, that is not a factor, and that is not a 0.